Good morning students. Today we are going to discuss few topic from the chapter 3, that is your current electricity. Now the first topic which you are going to discuss is your effect of temperature on resistance. Now if you increase the temperature of a conductor, what happens basically inside the conductor? Now inside the conductor there are free electrons are there. Now once you increase the temperature, what happens? The electrons move randomly in all possible direction, or you can say the kinetic energy of the electron increases. Now as the kinetic energy increases, there may be the collision between the electrons. Now once there is a collision, it means there is a change in velocity. So change in velocity means some kind of acceleration will comes out, and as a result some forces develop, and that force retards the motion of the electron. Now as the motion of the electron retards, so what happens, if you try to count the number of electrons that comes out from a particular area of cross section, now it decreases. It decreases means there is a less amount of current flows now. Now less amount of current means more resistance. So basically if you increase the temperature of a conductor, the resistance increases. Now we are trying to find a mathematical expression for the change in resistance with the change in temperature. Now the first topic, effect of temperature on resistance. So let you consider at temperature T0 degree centigrade, the resistance is your R0, and at T1 degree centigrade the resistance is your R1. Now definitely T1 is more than T0. So the change in temperature delta T is your T1 minus T0. Definitely it is in degree centigrade. Now change in resistance will be R1 minus R0. So R1 minus R0 or delta R define the increase in resistance because there is an increase in temperature. Now experimentally it is found that this change in resistance is directly proportional to the difference in temperature. If the difference in temperature is high, then the change in resistance will also be high. For example, if you consider the initial temperature is your 30 degrees centigrade, and if you increase the temperature to 50 degrees centigrade, it means 20 degrees centigrade you have increases. So there is a change in resistance will occur, and simultaneously you perform some other experiment considering one is your 20 degrees centigrade initial temperature and final temperature is 80 degrees centigrade. So definitely the difference is your 60. So increase in resistance will be high. So if you increase the temperature, definitely the resistance also increases. It means if you increase the temperature drastically, what will happen? The change in velocity will be very high, and as a result resistive force will be very high. So now less number of electrons will comes out through a particular area of cross section of the conductor. So this is your number one factor. So change in resistance is directly proportional to the difference in temperature. If the difference in temperature is high, then the change in resistance will also be high. Now also it is found that change in resistance is directly proportional to the initial resistance. So initial resistance is your R0. So combining these two, you will get delta R proportional to R0 delta T. So if you want to bring one equal sign, you have to bring one constant of proportionality. That constant of proportionality is your alpha. So alpha is your temperature coefficient of resistance. So alpha is your temperature coefficient of resistance. So the simple mathematics, delta R is your nothing but R1 minus R0 alpha R0 delta T. So if you simplify, keeping R1 one side and R0 another side, so R0 you can take out common, so it is your 1 plus alpha delta T. So final expression is your R1 equal to R0 1 plus alpha delta T. This formula is very important because numerical used to come, and also you can try directly the formula in the exercise numerical. There is one numerical in the exercise, just you have to substitute the value, and after that you simplify to get the final resistance. So this is one topic, effect of temperature on resistance. Now the next topic which we are going to discuss is your color code of resistor. Now the board is little bit unclear in the sense once I am trying to clear the board, some chalk dust are there already, that's why the background is like this. Now next topic we are going to discuss, but I think it's completely visible. Now next topic which we are going to discuss is your color code of resistor. Now under this topic I think most of you have seen this kind of configuration inside the circuit, maybe inside transistor, maybe inside any electronic gadget. There is a cylindrical conductor, and over that there is a color band. So by using this color band you can find the resistance of the conductor. So for that we have to use this topic, color code of resistor. So you see there is a code against the color. So two column, one is your color and the other one is your code. So color is your black, brown, red, orange, yellow, green, blue, violet, gray, white. So starting with 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So you have to memorize this table. Now how can you memorize this table? Always in code you memorize the registers from 0. Now in this side starting is your black. So there is a method of memorizing this table. So the method is like this. Under note I have written. So initially B.B. Roy, the person, B.B. Roy. B for black, second B for brown, R for red, B.B. Roy. You have to memorize this statement. Once you memorize this statement, you can memorize the table. So B.B. Roy, great, G-R-E-A-T. This G will get counted. That is your B.B. Roy. B for black, B for brown, R for red, O for orange, Y for yellow, G for green, great. Under the great, first G is for green. Great Britain, B for blue. Very, V for violet. Good, G for grey, and wife, W for white. So you have to memorize this statement, B.B. Roy, great Britain, very good wife. So once you memorize this statement, you can make the table starting with, but don't forget to consider the starting B as your black. If you consider starting B as your brown, then everything will mess up. So B.B. Roy, great Britain, very good wife. So B for black, B for brown, R for red, O for orange, Y for yellow, great, G for green, B for blue, for Britain, V for violet, G for grey, and W for white. So B.B. Roy, great Britain, very good wife. So this one you have to memorize. So it is like this. B.B. Roy, B for black, B for brown, R for red, B, O for orange, B, R, O, Y for yellow, B.B. Roy, great, G comes out, that is your green. Britain is your, B comes out, that is your blue, and very, V comes out, that is your violet, good, that is your grey, white, W, that is for white. So B.B. Roy, great Britain, very good wife. So starting with 0 and starting with black. So this starting with 0 and starting with black, these two things you have to keep it in mind and simultaneously to memorize the statement. B.B. Roy, great Britain, very good wife. So this table you must have to memorize if you want to find out the resistance of a resistor using color code. And apart from this table, this also you have to memorize. That is your color, gold, silver, and no color. So tolerance basically plus minus 5%, plus minus 10%, plus minus 20%. So this whole table you can memorize like this. BB Roy, Great Britain, very good wife. That's why BB Roy offered some gift, and that gift is nothing but some kind of gold and silver. So color for gold is your plus minus 5%, silver for plus minus 10%. If there is no color, then it is plus minus 20%. Basically, in color code there are 4 bands. This is your first, starting from left, first, second, third, fourth. So this part I have taken as an example. Fourth band, first is your black, second is your brown, third is your red, and fourth is your gold. So how do you write the value of the resistance if this color exists? So the formula is your first color, keep it within the bracket, second color, keep it within the bracket, into 10 to the power third color, and plus minus tolerance. So first color is your black, so this is your black is 0, so I have substituted 0 here initially. Second color is your brown, so brown is your 1, so I have substituted 1, just to place, into 10 to the power third color is your red is your 2, so 10 to the power 2, and plus minus tolerance as it is gold, and gold is your tolerance plus minus 5%, so plus minus 5% of that initial value, that is your 0, 1 into 10 to the power 2. So 0, 1 into 10 to the power 2 ultimately comes out, it is your 100, 5% of 100, so 5 by 100 into 100 goes off, so 100 plus minus 5 ohm. So in exam it is asked to find the value of the resistance using, or value of the resistance of the resistor using color code. So this table you have to memorize. So this topic is a little bit interesting, so please go through this topic and find out your doubts. Let me to show you once again. This is, I think it is visible, though little bit whitish color is there. The formula is your first color, second color into 10 to the power third color. First color and second color, this is not multiplication, it is just you have to place first digit, second digit, like that. Plus minus tolerance. When you go through this topic, please compare this topic with the reference book. I think most of you have your reference book. See this statement. BB Roy, Great Britain, very good wife. BB Roy, black, brown, red, orange, yellow. Red, orange, yellow, it comes from Roy. Great, G. Britain, B. Very, V. Good, G. And wife, that is your W. Okay, this is all about. Please go through this topic and clear your doubt. Thank you.